We know that there are two poles in a magnet, a north pole and a south pole. So according to the law of magnetism, like poles repel and unlike poles attract, which means if we bring two like poles together, means both north pole or both south poles. So if we bring north and north or south and south together, we will experience a repulsion force. They will start repelling each other. But if we will bring two unlike poles together, means one north pole and one south pole, then they will attract each other. Therefore, like poles repel while unlike poles attract each other. We can verify the law of magnetism with the help of a simple activity. Take two bar magnets, suspend one of the magnet freely with the help of a thread. Now hold the other magnet in your hand. When the suspended magnet come to rest, you will see it will come to rest in north-south direction because a freely suspended magnet rests in north-south direction. Then bring the north pole of the magnet which you are holding in your hand towards the north pole of the suspended magnet. When both like poles will come closer to each other, you will see that the suspended magnet will start moving away from the magnet which you are holding in your hand, which means that the suspended magnet is repelling the other magnet because you have brought the north pole, that is the like pole, towards the north pole of the suspended magnet. So you will see that both the magnets will not touch each other. Now bring the south pole of the other magnet which you are holding in your hand towards the north pole of the suspended magnet. You will see, even without touching the magnet, that suspended magnet, the suspended magnet will come and attract with the magnet which you are holding in your hand, which means that both unlike poles, north and south pole, both the unlike poles are attracting each other. Thus we can see that like poles repel while unlike poles attract each other. Repulsion is the sure test for magnet. The reason is that because magnet can attract magnetic substances also. Like if we bring an iron rod near a magnet, then magnet will attract that iron rod, as well as magnet attract the unlike pole of other magnet. Like if we bring the south pole of one magnet towards the north pole of other magnet, then again you will see attraction between both of them. But in a magnet, if we bring two like poles together, then repulsion will indicate that both are magnets. Therefore, we say that repulsion is a sure test for magnet because repulsion do not take place in iron. It takes place only between two magnets when two like poles come to closer to each other, then repulsion takes place. So repulsion is the sure test for a magnet. We know that in a magnetic compass there is a needle which rests in north-south direction. When you bring this magnetic compass near a bar magnet which is placed on a table, you will observe that the magnetic needle of the compass will start swinging, means it will not rest in north-south direction now. It will start swinging in different direction. As we will change the position of magnetic compass at different points around the bar magnet which is placed on the table, if we change the position of the magnetic compass, then you will see that the needle will also change its position. So this means that there is some property, this space around the bar magnet has some property which is influencing the magnetic needle of the compass, due to which that needle is now not resting in north-south direction, but it is swinging and moving in other direction than north-south. So this space around the bar magnet in which magnetic compass gets influenced, that space is called its magnetic field. So whenever a magnet is placed at any place, any table or anywhere, then it creates a magnetic field around itself. In that magnetic field, if you bring a compass, magnetic compass, then you will see that the needle of that magnetic compass will not rest in north south direction. It will start swinging and it will rest in any other direction other than north south. Electromagnets. In 1819, a Danish physicist, Hans Christian Ørsted, discovered that there is a magnetic field around every current carrying wire. So if there is any wire in which current is flowing, there will be magnetic field around that wire. This electromagnet is now widely used. We use electromagnet almost everywhere, in electric bells, in motors, telephone, fans, mixers, air conditioners, everywhere electromagnets are used. These electromagnets are also used to lift heavy iron loads. So electromagnets are widely used nowadays. To make an electromagnet, we have to wound an insulated copper wire around a cylindrical cardboard. The length of the cylindrical cardboard should be much more than its diameter. Now we will get a cylindrical coil. This cylindrical coil is called as solenoid. There will be two ends of the wire. Connect these two ends using a dry cell. We have to connect the two ends of the wire with a dry cell, then current will start flowing in that coil. As soon as the current will start flowing in the coil, that cylindrical coil will start behaving like a magnet and it will produce magnetic field around it. So this magnet is called as electromagnet. Electromagnet because it is behaving like magnet in the presence of electricity. That is why we call it as electromagnet. Now the polarities means which pole will be north and which pole will be south. It depends on the flow of electric current. The end of the electromagnet in which the direction of current is anti-clockwise, it becomes the north pole, and the end where the direction of current is clockwise, it becomes the south pole. So as you can see at end A, the current is flowing in clockwise direction. So this end is called as south pole. This right now this end of the electromagnet is the south pole, while at end B the current is flowing in anti-clockwise direction. So this end of the electromagnet is the north pole. So this way we decide the north and south pole of an electromagnet. We can also interchange the north and south pole in an electromagnet by interchanging the flow of current. If we change the direction of flow of current, then these poles will interchange also. To increase the magnetic field of an electromagnet, we can follow the three ways. First is by inserting a rod of soft iron or steel inside the cylindrical tube. So if we use the core material as soft iron or steel, then the electromagnetic field of an electromagnet can be increased. Second, by increasing the total number of turns of the coil. The wound of insulated copper wire, if we increase those turns, number of turns, then also the magnetic field of an electromagnet will be increased. And third, by increasing the strength of current passing through the coil. So the strength of the current, if the strength of the current passing through the coil is increased, then also magnetic field of an electromagnet can be increased.